Okay, so I guess everybody has solved this this challenge of building a continuous integration and deployment pipeline, and we have managed to build our code, to test our code, and to publish the code to Azure Web Apps. We now have a little bit more than half an hour left in our lesson today, so I would like to go into a last topic, which is not that obvious, and it will hopefully be interesting for you and will hopefully maybe surprise you a little bit what GitHub Actions is really able to do. Think of the following scenario. In the last months, we have built a bunch of APIs, and in these APIs, we're using Entity Framework to access Microsoft SQL Server. Now, imagine that you would like to build an integration test. That means an automated test, which does not just check a small piece of logic, a small unit of logic, which is called a unit test, but which tests a larger, let's say, orchestration of multiple processes. And in our case, it could be, with Entity Framework, a process that really accesses the database. So we need to be able to run integration tests that need a database. Let me just say a few words in order that you understand when to use integration tests and when to use unit tests. The vast majority of your tests should be unit tests. So small tests which just test a small piece of code. If you take a look at some of the exercises that we did in the previous weeks, if you take a look at some of the exams that we did in the previous months, then you can remember, hopefully, that I sometimes gave you tests which were just checking the correctness of certain elements in your code, small algorithms that you had to write. Such tests are called unit tests. And integration tests are tests which require a larger setup. For instance, your API, your application logic, and the database in order to run them. You shouldn't overuse integration tests. So the vast majority of tests should be small, tiny unit tests. In the second semester, we will also take a look how you can isolate some pieces of logic which have dependencies on larger other pieces of logic. We will do that in the upcoming months. But for today, I would like to close today's lesson by showing you how you could create an integration test, because sometimes integration tests, especially in conjunction with the database, with databases and Entity Framework, are super useful. Now, our focus today is not so much on building a real-world C# application with Entity Framework and so on. We could do that, but our focus is continuous integration and continuous deployment. So we will just write a dummy test which just connects to a small database which runs, if we do it in Visual Studio on-premise, in SQL Server on-premise in our machines, which will use a SQL database in the cloud in Azure once we have deployed it in Azure. But the problem is we will need a database during executing the unit tests in Azure, in GitHub Actions too, and that will be the very specific things. How can we get a temporary database in Azure, in GitHub Actions, while we are running our tests, okay? This is what we are going to do. This is what I want you to show, okay? Good. So let's go into our small little sample application and let's create the smallest possible, most simple setup of Entity Framework which we could think of, okay? The simplest thing what we could do. This is what we want to do here. So let's do that. Please go to Manage NuGet Packages and add the necessary NuGet packages that we need. Again, this is not about Entity Framework. We will just do the minimum setup for creating a trivial table which just connects a single column. It's not about details about Entity Framework, but still we need to add the necessary dependencies. So go to the NuGet Package Manager, look for Entity Framework, and in Entity Framework, add Entity Framework SQL Server. You should know that by now. Good. And add the Entity Framework Core design NuGet packages. We have done that over and over again in the last weeks, and I hope you can remember that one. Good. Nice. Now let's quickly add in our, not test project, in our API project, let's quickly add a new class. Let's call it data, and we will simply put all the things, all the code that we need to set up here directly in this data file. To make things simple and in order to speed up a little bit, you do not need to follow along. I will now type in the necessary code, and then I will copy it and use a web clipboard to share this code with you. There is no need to follow along, okay? It's just a very, very simple demo here. So let me on the side open my my cheat sheet. Yes, I'm also using the cheat sheet because I don't want to type in everything by hand. So what we will do is we will do a public class, let's say customer. Very simple. Let's use a property int ID. You all know how that works. And use a property string. That's the customer name. That's it. That is our entity. This is what we want to store. Next one, we would like to create a database context. Let's add that one. Let's change it from blogging context to customer context. As I told you, I will share this code in a second with you, so you do not need to follow along. We will focus on continuous integration and delivery. And here we will reference the customer, and this is called customers. Looks good. That is all we need to do in order to get the database context up and running. Now in our startup method, if you can remember what we have to do there, last time we discussed that in very much details. We have to use the configure services method and use the customers context here. For external viewers, I think I called it customer context, right? Yes, for external viewers, please watch the other videos that I published in the last weeks and months if you don't know what I'm doing here. Okay, the database context is here. This is exactly what I wanted to do. That looks good. I like that one. Let's build everything and see whether that works. Looks good. Let's go into the console. Let's go into the animal API project and let's say .NET EF migrations add initial, and if that works, I will share the code with you. Ah, I forgot the app settings. I forgot the connection string. I'm sorry about that. Let's copy this one here. And let's call it CI CD demo, something like this. Again. Much better. Database update. Let's see. Yahoo, it worked. So let me share the code with you in order that you can follow along. So I will copy that one. CI CD demo. Let's do that one and paste the code here. And let's keep it up for an hour, create the clip. This is the URL. Go to this URL here and copy the code. I will put it into Teams chat, so you don't need to type it in. Here is it. Please take the code and put it in your project. I will wait for a minute in order for you to catch up. And also don't forget to add the database context here, okay? Also again, don't forget the connection string in your app settings JSON file here. I will wait a few more seconds until everybody could catch up. If you have any problems, please let me know. And don't forget to create your migrations and do the database update. .NET EF migrations add, .NET EF database update, just as we did in the last weeks over and over again. Okay, does anybody need more time, or do you have any problems setting up your data context and setting up the database? Any problems? Does anybody need more time? Are we good? Good. We are good. That's good. That's good. Now let's add a very, very simple controller. Right click on the controllers, choose Add Controller, API, Empty Controller. Let's call it here Customers, plural, Customers Controller. And let's do two of the most trivial things that we can do. Again, this is not about deep dive ASP.NET Entity Framework. We have done that in the last weeks. We are just setting up something in order to get going with continuous integration and deployment. So add a constructor and get your customer context. Good. And then let's add an HTTP GET method. Public async task I enumerable customer get all, and here we just do a context customers to array async. That will just query, oh, I forgot the wait, sorry. That will just query all the customers and return all the customers. Very, very simple. And last but not least, HTTP post, not patch post, public async customer add customer C. Let's add a from body here to make sure that it comes from body, and do a context customers add C await context save changes async. Good. Yeah, and return the customer that we just did. I know here we are missing some. Why? What's the problem here? Oh, of course. Task. No, it's good. Yes, I know we are missing some beautiful error handling, and we should really return iasync result and things like that. It doesn't matter. The core of this exercise is not writing the most beautiful ASP.NET Core controller. It's just an experiment, and we just want to get something in order to be able to try out our API. That's all, nothing more. Good. I will wait for some more moments so that everybody can catch up. I promise we will only write maybe 10 lines of code, and then we will dive right into continuous integration and deployment. While you're catching up, I will quickly take a look at my database, whether it was created successfully. It should, yeah, here it is, looks good. Do we have a table? Yes, here is the table. And if I take a look, yeah, nothing is in here. Let's add foobar just to have one record in the database. Good. Yeah, fine. What? Good. I just manually entered one record in the database. It doesn't matter. Good. I will quickly check whether my API controller works. I will run it. And I will go to customers. I think it was called API. And here is my record. If you haven't added a record through Data Studio, this will be an empty array. That's perfectly fine too. That's not our core thing here. It's just taking a look whether it can successfully open the database. That has been easy now. We just created a very, very simple database application. But now we would like to add a test, and this time an integration test to our application. So what we want to do is we want to write a test that first deletes all the data from the database, then creates a controller, calls the add method with a single customer, and then calls the getAll method and checks whether the controller will return the customer that we just added. This is meant an integration test because we are testing the controller together with our entity framework data context, together with a real-world database. This is why it's called an integration test. And again, I know I repeat myself. The vast majority of your tests shouldn't be like that. They should be unit tests. But here we are talking about continuous integration and deployment, and therefore we need to talk about when we want integration tests. How can we get them? How can we run them in GitHub when there is no database? That is the problem we are going to tackle, okay? So let's write the unit test. Let's go to the unit test. You know what? It's so ugly here. Unit test 1. I will rename it demo tests. That's fine. And now let's add a fact here and let's write a small unit test. Good. Public async task my integration test, or let's call it customer integration test. Good. Something like this. I'm missing a using here. Let's add the using. Okay, now it's good. Now, what should this integration test do? It should create a DB context. It should create a controller. It should add a customer. And it should check, does getAll return the added customer? This is our test scenario. Oh, I forgot one thing. Just to make sure, delete all existing customers in the database. This is our test setup. This is what we want to do. This is the scenario of the integration test that we want to implement. Good. Let's do that. First, we need the app settings file for our test project. So what we are going to do, and I encourage you to do the same, take the app setting file here and just move it up. Press the Control key in order to copy it. So copy it into the test project. You can delete the app settings development file. We will not use that currently. And to make sure, right click on the app settings JSON file, go to properties and make sure that build action is none and copy to output directory is copy if newer. This is the correct setting for the app settings file. Build action is none, copy if newer. This is what we want to do. Now, understand, this app settings file here contains the connection string for the tests. And this app settings file contains the connection string for the API when we want to debug it. So with this setting, by having two separate app settings files, we can easily control the connection strings for each application. So for instance, I will do here CI/CD demo _ test because I want to use a separate SQL database for running my tests. So I opened app settings JSON and I changed the name of the database in the connection string. Nice. Good. So let's write this test. Only a few lines of code. First, we need to create the database context. The necessary code can be found in the cheat sheet. So just to refresh your memory, we had the database context factory if you can remember that one. And here you see how to create a data context. So what I will do, I will just copy that one and make it a little bit more easy. You can just type the code as I have it here, or I can share it with you. We have done that many times. We need another package. Let me see. Oh yeah, I did not. Let me see. We are missing. Which one do we need? Configuration builder is not here yet. The database context. Ah, of course, I forgot something. I'm very sorry. We currently have the test project and we have the API project, and the test project does not yet reference the API project. I forgot to set the dependency. I'm sorry for that. Right click on dependencies, add project reference, and add the API project. Okay, please do that. Add the API project. And now you see we can generate the usings. Sorry that I forgot these dependencies. It's called customer context. We don't need all this stuff here. Make it simple. Again, a using is missing. And again here, the customer context. Good, first step done. So take a look at this code. This is the code that you need to write. Just 4 lines of code. You can also copy parts of the code from the cheat sheet, and I will again wait for a minute or so in order for you to be able to catch up. And don't forget to set the dependencies from the tests project to the API project. I forgot that one. Don't do that. My mistake. Sorry about that. Anybody having any problems? Good. Let's continue. Next step, just to make sure, delete all existing customers in the database. Well, that one is really simple. We just go and say context dot customers dot remove range context dot customers, I don't know, to array async, something like this, and put an await here in front of it, and that's it. That is a very simple way of removing all the customers. Let's do, just to make sure, await context dot save changes async. Good. Now we deleted all the customers. Next one, let's create the controller. Var controller equals to new customers controller. And it needs the database context as a parameter. No problem, we already have the database context. Next step, add a customer. Using the controller, we are testing. We are using an integration test. So what we do is controller dot add, I think it was called add, right? Yes, it gets a customer, new customer, and let's add the customer name foobar. Wait context dot save changes async. Sorry, add already does the save changes, right? I'm sorry. We don't need these save changes here. I forgot what I coded just a bunch of moments ago. Wait, everything is fine. This is adding a customer. Please interrupt me if I'm too fast. It's important for me that you have enough time to follow along. Good. Now let's call the add method. var result, the get method, controller.get all. And that will give us, wait, of course, that will give us a list of all customers. And now we need to make sure that we just got back this customer. So what we can do is we can say assert single result. That means there has to be a single customer in the list of customers returned here. And then we can also say assert.equal foobar result. What did get all return? And I enumerable. Okay, I have to do a to array here. What did? Ah, yeah, here. I had to do a to array and check the element 0 with customer name. So we check that we get a single customer and it has to be foobar. That has to be the name. And with that, we have written an integration test. An integration test which tests everything from the controller to the entity framework data context down to the SQL Server. So this is your code, this one. I will wait for a minute or so until you have finished to catch up and type in this code. This is a very typical integration test. Are you curious if the test works? Well, I am. So let's go to the Test Explorer and run it. It fails. I know that it fails. That is not a surprise, because if you take a look, cannot open database CI/CD demo test. Well, I just changed the app settings here, but I never created the database. I never did a .NET EF database update. So there is no database, and therefore our whole test breaks. Doesn't work yet. So do we have to do this database update all the times? Is that really necessary? Well, yes and no. We could work like that, but today I would like to show you a little bit different option, because you can trigger this creation of the database, especially in tests, if you do it in code. So after creating the context here, what you can do is you can say context.database.ensure deleted. That will, oh, I think there is an async version of that too. That will drop the database. That will drop the database. That is optional. You don't absolutely need to do that. But in my case, I will do it. And then I will say await context.database.ensure created async. And that will create the database. That line is essentially the same as running .NET EF database update in the console. So that is really dropping the entire database and creating the database from scratch. And if you think closely, then we can remove that one, right? We don't need to manually delete the customers. By dropping the database and creating the database from scratch, we can now, watch what I'm doing, delete this code. We don't need it, and just move that one down here, because these two statements will make sure that we always start with on a fresh slate. We start with a fresh database. Now, you can imagine that dropping a database and creating the database from scratch takes a little bit of time. And this is the reason why you shouldn't do too many integration tests. Unit tests, they are fast. They should be fast. Integration tests that interact with the database, for instance, they are slower. And if you have dozens, hundreds of these kinds of tests, your continuous integration process will take quite a lot of time. And that is annoying, to be honest. So avoid integration tests, but don't drop them. They are valuable. In some cases, they are really, really important. This is now making sure that everything works from the controller to the entity framework to the database. So it is It has value, but we have to be patient because it takes a while. If you did that, we can try it again. Test Explorer, run it. Nice, green check. We have an integration test. And do you see the difference? This might be a unit test, 1 millisecond. And this is a typical integration test, 1 second. That's very long compared to unit tests. But to be honest, 1 second, it's fine. But now we have a nice integration test. Creating the database context, dropping and creating a new database in order to have a fresh slate. Create the controller, use the controller methods, and make sure that the controller methods return the correct responses. Okay, this scenario is simple. We are here in a beginner's course, but you should see the principle here. Please try that. I will wait for another minute or so. We only have one step left, and we have, I think, a quarter of an hour left in the lesson, so we are good in time. Make sure everybody who wants to type in and follow along, catch up, type in the necessary code, check whether the test runs. If you have any problems, please let me know. Does anybody need more time, or does anybody have problems? Anybody where the unit test, the integration test doesn't work yet? I haven't heard any problems yet, so I hope you could all follow along. So we can now switch our attention back to our build pipeline. You see, the problem is when we now run this build pipeline and it comes to creating these unit tests, running these unit tests, they will fail. Why will they fail? Well, because the app settings JSON file references local DB. And guess what? There is no local DB in GitHub. It doesn't work. It will not find the database server, therefore it crashes. So that doesn't work. We need to somehow spin up a database dynamically in GitHub Action. And this is what I want you to show. The beautiful thing of GitHub Action is that it's built based on container technology. I think you have at least heard about container technology in other courses. If you haven't, don't worry, you will be able to follow along even if you haven't heard about container technology or haven't used it. But the important thing is it's built in GitHub Actions. And how can we use it? Well, what we do is after the system has installed .NET 5, we will use here another step. Let's say name and call it Start SQL Server. So we will on the fly during running our continuous integration pipeline spin up a SQL Server inside a Docker container. Inside a container. And we can do that because these containers are built, these container engines, they are built into GitHub Actions. And that's super, super useful. How do we do that? Let's say run and use the pipe so that we can start the command in the next line. Pipe means that we can write multiple lines of script code here, or longer lines. It's just, yeah, if you have it in the same line, you don't need that one. If you have it in the next line, use the pipe here. So what do? We say Docker run. Now what can we run? Let's take a look at the browser. Where is the browser? Here is the browser. We have to go, you don't need to follow along here. You can copy the code from me then. But if you go to hub.docker.com and look for SQL Server, then you will see that Microsoft publishes ready-made so-called container images for their SQL Server product. So what we can do is we can, during the continuous integration process, pull down a version of SQL Server and spin it up and make it available for our tests. If you scroll down a little bit, then you will see, for instance, this line here. See that one? It uses the Express version of SQL Server, which is free. So we don't need to pay for SQL Server. So I will copy this line and paste you that line in the chat window, okay? Oh, that doesn't look beautiful. Let me see. That somehow copied some strange text formatting. I'm sorry. Now you get a better version. So please go to your chat window and paste in this Docker run statement. This one just accepts the end user license agreement. You have to do that. It's like when you install software. Do you agree the terms of license? Yes, okay, check. Then choose any kind of password. Any password that you like, and I will use, which one will I use? Let's see here. Let's use pass and word. Something like this. Please use any kind of special character. Please use some digits, some letters, some uppercase and lowercase letters, whatever you want to have. And for the version, we can even use the latest version of SQL Server. So I will just use the latest, not some 2017 something, but just use :latest to get the very latest version of SQL Server. And this is the magic of having Docker containers available inside of GitHub Actions. We can really pull down any kind of database and use it during testing. Do you want to use Postgres? Then pull down a Postgres image. Do you want to use MongoDB? Then pull down a MongoDB image. Do you want to use any other system that you need for integration testing? This is the way how you can pull it down from Docker and start a version of this file. The only thing that you have to add, and please watch what I'm doing now, at the beginning, add a -d, this one. That means detached. If you don't add this -d here, then the whole build process might stop here and wait until the server finishes. Well, it will never finish because it's a server. So therefore, we need to run it in a detached mode. That means continue running the build pipeline. Don't wait for the server to end. It will never end. Therefore, detached, important. Now, spinning up the server obviously takes a few seconds. So we have to wait for a few seconds. And luckily, somebody created a GitHub action which is just there for waiting. Let me show you this GitHub action. It's pretty useful. If I Google it, I regularly use this one. It's a very, as the name suggests, very simple action for sleeping. And all you need to do is you need to copy this code here. See? I will take this code and put it again in the chat window so you don't need to look it up yourself. Now you have it in the chat window. Again, it's strangely formatted. I'm sorry. Teams sometimes copies the format. Now you have the beautiful code here. So what we do is we go to our action here and just paste this one in. Okay? I think 5 seconds are fine. We don't need to wait for more than 5 seconds. We need a beautiful emoji here, of course. Sleeping for 5 seconds. We do that because SQL Server will take a few seconds to come up. That's normal. I mean, that's a big database. It's capable of doing very interesting stuff. So therefore, 5 seconds of wait for boot time is okay. And with that, we are nearly done. The only problem that we have is that we need, in our app settings here, we need to change the server name and provide username and password. How can we do that? We can override the settings in app settings here when running the tests. So here at the test step, see, run automated tests, we will say environment variables, because in the environment variables, we can override the settings. We have talked about that before. We can override the settings here. And how do we do overriding of the settings? We write here app settings connection strings, that one, underscore underscore default connection, and then we can add a changed connection string. So we take that one, copy the connection string, put it here, and now we can change server and username and password. Localhost, because it spins up the SQL Server locally. And instead of trusted connection, we say user, system administrator, and password, and then we copy the password from up here. That was the second last line of code. We have 5 minutes left. I hope we will manage to complete that. I hope we will manage to complete that. Please try to follow along. So what we now did is this one, and this one. And then hopefully we will make it work. Let's see. Anybody needs more time? Ready for the last line of code that we need? Whoops. The last line of code that we need is we need to change our integration test a little bit, because now the integration test only reads from app settings JSON. In order to make it read the environment variables too, we need, after the add JSON file, add environment variables. This setting here from environment variables and JSON file will make sure that the environment variables, see the point here, environment variable here, can override the settings from app settings JSON. This behavior is default for web APIs, but for unit tests, we have to mimic it. So we need to add these two things. And now we are done. We have 4 minutes left. Let's see whether we can finish with a green check. Maybe something will break. We will see, but we will definitely give it a try. So, if you followed along, you can be proud of yourself. We check everything in. Add integration test. If not, and if you have just followed along conceptually by watching me typing, that's fine too. Push it. I want to at least see the SQL Server coming up. If the test broke, well, we will see how much time we can spend fixing all this stuff, but yeah, let's see. Maybe we are lucky. Let's go back to our browser. I have somehow, yeah, here it is. Add integration test. Crossing fingers, crossing fingers. I hope I didn't screw up. Good. It checks out the code. That worked. Well, we have seen that working over and over again, so that it wasn't a surprise. Setting up .NET 5 also looks good. The next one, Start SQL Server, will be the interesting one. Nice, you see, this is Docker. So it's now in GitHub Actions, pulling down the latest version of SQL Server. and it's starting up the latest version of SQL Server dynamically on the fly. And this is what I wanted to show you with continuous integration. So by using container technologies, we can dynamically build really complex server infrastructures during the build process. Now the download of the image is complete. I don't need to set it up. I don't need to install it. I don't need to maintain it. It always gets the latest version of SQL Server for our integration tests. So now it's sleeping for 5 seconds. Ignore this warning. It's not important. It's done. 5 seconds. The important thing was already successful. It would be really nice if the tests also succeed, but I don't promise that. It was a complex demo, so maybe I screwed it up. And we only have a minute or so left. So if we get a red cross, don't be angry with me. I will show you the solution next time. But now, keeping your fingers crossed. Oh yes, I think we are lucky. I think we are lucky. In the last minute, in the finish line, we got automated tests. See that one? We were fighting so hard to get this number here, past 2. So what we did now, and that is not a trivial thing, if you understood what I did, or if you even could follow along, that is a non-trivial demo. We now built a complex continuous integration pipeline with integration tests by spinning up dynamically a database server inside of GitHub Actions. And then building everything, testing everything, and at the end, you see it, successfully deploying everything in a cloud environment. That is real-world continuous integration and delivery. And please keep in mind, we didn't spend a single second setting up virtual machines, installing Linux, installing some software, maintaining SQL Server. We can run that for the next few months, and we don't need to spend a single second on installing updates or patches or anything. It just works. It is just there waiting for us to push code, and it will do all the things automatically. I am really happy that we could finish with that at 12:41. I used 1 minute more of your time than we had in this lesson. I hope you are not angry with me, but I hope you enjoyed this demo and this lesson. One last thing, and it is a very important thing. Go to your Azure subscription and delete the resources. Otherwise, your benefits, the $100 that you get per year, will be burned pretty quickly. So if you don't need Azure resources, delete them. I will do that. I will now delete the entire application in order to save money. So don't forget that. So in your student account, delete it. With that, I want to close today's lesson. I would like to wish you a beautiful week of holiday, and we will see each other in 2 weeks. If you have any problems, any questions, if you do your projects during holidays and you have problems and need support, don't hesitate to contact me via Discord or email. With that, let's close today's lesson, and I wish you a nice day and nice holidays. See you in 2 weeks.